Okay, so now we start really the heart of Unit 10 in AP Calculus. And I want to read this bold question first. This is the thing to always be thinking as we're going through this unit. The primary question we ask about series is if the series converges or diverges. We just want to know that. We want to know, does the series approach a number or not? We will now spend a few modules learning how to identify what type of series we have so that we know how to determine whether it converges or diverges. There are different tests we apply depending on what we see in the series. That first paragraph is so important that you need to read it again. So you might pause this video and read that again. Please always keep in mind what we're trying to do in this unit. Now, before we start with our first couple of types of series, I want to go to this roadmap document. Because as we work through all of these lessons, AP topics 10.1 to 10.10, we're always asking, is the series converging or diverging? And what we're going to find is that we're going to have a series of tests that we're going to use depending on what we see. We're always looking, figuring out what kind of series we have and what kind of test we need to apply to it to know if it's converging or diverging. And there's a lot here. This is all from lessons 10.2 to 10.10, AP topics 10.2 to 10.10. And we're going to start here with these first two in this video. We're going to say, okay, if we can identify we have a geometric series, then we'll know it's converging or diverging based on these rules. Or if we know we have what's called a p-series, we'll know if it's converging or diverging based on these rules. Now, I want to say one thing because since it's going to happen on this first type of series, it's tempting to think this always happens. But for a geometric series, we can actually evaluate the number that we converge to, the limit. In just about every other scenario we're going to look at, we cannot figure out the actual answer that it converges to. And remember, the question isn't, what does a series converge to? The most important question is, does the series diverge or converge? You're just answering that and showing why that's true. A geometric series, which is going to be our first type we're going to look at today, is really one of the only scenarios that we can actually find the answer if we know it converges. So try not to let that confuse you whenever we do that, but then we don't do it anymore. Okay, so let's start with geometric series. We're going to look at two series in this video, a geometric series and a p-series. They're both pretty easy to deal with and super important that you get these ideas memorized. So a geometric series is a series where the terms change by multiplying by a constant ratio, r. So for example, if I said r is 2 and my series is maybe 3 times r squared. So we're going to start at 1. So the first one would be, my sequence is 3 times r squared. So my first term would be 3 times 2 to the first power. Actually, I shouldn't say squared. It's to the whatever term we are, nth term. So that would be 3 times 2, 6. My second term would be 3 times my constant ratio or common ratio 2 to squared, because now we're on the second term, so 3 times 4 is 12. My third term would be 3 times the ratio to the third power, 3 times 8, 24, so on and so forth. Now, we don't care about sequences like that, we care about series, so we would be adding those numbers together, 6 plus 12 plus 24, going on however far we need to go, usually to infinity. Now, geometric series can also divide, but instead of thinking dividing, think of your r as being a fraction. All right, so let a and r be numbers. Number 2, let n be the term number in the series. So how many are we going to look at in this sequence? Let b be the upper bound, and that can be a number, or often it's infinity. And so this is how we write a geometric series. I'm going to highlight this in orange. Important to learn a geometric series, the 3 foundational parts. A is just some numbers that makes the function more interesting. R is whatever your common or constant ratio is, and n is what term number you're on. Okay. Now, a can simply be 1, so it might not even be there. It might be hidden, or it can be any other number. N can start anywhere. It doesn't have to start at 0. You might see it start at 1 or 2 or anything, really. The key idea is that a geometric series has some number to the nth power. This is really how you are identifying a geometric series. Some number raised to the n. The n is the term number in the series. So you are trying to identify some number raised to an n, and that makes this a geometric series. These are all four examples of geometric series. Notice they all have something raised to an n. Okay? In this case, we have an A, we have an R, we have an R. A would be this hidden 1. In letter B, we have an A, we have an R, we have an A, we have an R. Okay? Now, we notice that that's raised to a negative power, so that's kind of interesting, but still, you get the idea. Okay, so remember, what's the question we're asking? Up here in yellow, I'll highlight the top one in orange. We want to know, does the series converge or diverge? That's what we are trying to figure out. So here we go. Start important, number 4. A geometric series, that's what we're working with, okay? A geometric series will converge, and we can actually find the answer of that convergence, and we'll work on that idea in a second. If and only if your R is between 0 and 1. And let me say that again. Your absolute value of R is between 0 and 1. So that could be 0.5 or negative 0.4 or 0.9 or negative 0.01. Any of those would be an R where the series is definitely going to converge. If the absolute value of your R is outside of 1, so 1.1, negative 2.3, because remember absolute value, those all diverge. And so this is the primary, most important thing to know about geometric series. It's some number raised to an nth power, the n power, whatever that some number is, R. If it's the absolute value of it's between 0 and 1, then it converges. If it's greater than 1, it diverges. It's a very, very short, easy test for you to do. Now, let's look at number 5. So back up to our examples. So we're using the bottom of your screen, the top of your screen. Here we go. Letter A converges. Why? Because R is 1/3. And you're like, no, you're not. R is 3. Well, R is actually not 3 because this is 3 to the negative n becomes 1 over 3 to the n, which becomes 1/3 to the nth. And this is a thing that we're going to see a lot in these series, not a lot, but every once in a while, is 1 can take on an n power if it needs to, because it doesn't change it. So, back to number 5 here. In the examples in number 3 above, the following explains their convergence. So letter A converges because R is 1/3, because 3 to the negative n is 1/3 of the nth. All right, let's look at letter B. 0.5 to the n, so that converges because R is 0.5. Look at letter C. E to the n. Well, E represents what? 2.7 something. That's outside of a 0 to 1 bounds. So C diverges. And finally, look at letter D. 0.3 to the n. 0.3 is between 0 and 1, so that converges. Okay, so the primary question we're answering is, does it converge or diverge? You need to find the R. If the R happens to have a negative exponent on it, you got to do the little fraction thing like we did on letter A. Well, okay, there's one more thing that we care about with geometric series, because it's really the only series that we focus on what number actually converges to, because we can calculate it. And I kind of skipped over this, so I'm going to circle this now. Let's see, let's use this green color. It will always converge to the first term of the series divided by 1 minus r. Okay, that's written down here in number 6. To determine what a geometric series converges to, you must plug in your starting value for n. That's why it's important. I'm going to point up here. You got to look at where we start. Letter D, n equals 1. Letter C, n equals 0. Letter B equals 0. A, n equals 1. And you plug in that starting value into n and just kind of work out that, simplify that, and that will give you your starting value for the sequence. And that goes on the top of this fraction, the first term divided by then 1 minus r. So let's look at A, B, and D since they all converged here. So here we go. Since they converge, let's figure out what they are. Well, we need a starting value for letter A. So we're going to plug, let me zoom in on A here, n equals 1. So we're going to plug 1 in for n. So 2 times 3 to the negative 1. 2 times 3 to the negative 1 is 2 over 3. So that's our starting value. So then we're going to go our starting value divided by 1 minus our r. And we said that's 1/3 in this particular problem. So 2/3 divided by 2/3 is 2/3 times 3/2. All cancels out. We converge to 1. So letter A, if you kept adding 1 to that and then adding up all your answers, your series, you would find out all those answers go to 1. Well, let's look at letter B. All right, so we need to find the starting value for B. Now look at B. B starts at n equals 0, so we're going to plug 0 in for n. Well, 0.5 to the 0 power is easy. Anything to the 0 power is 1. So that's going to be 0.5 to the 0 power, which is 1. So it's going to be our starting value 1 over 1 minus r, 0.5 or 1/2. So that's 1 over 1/2. Divide by the reciprocal, and that converges to 2. And now let's look at letter D. So letter D, zoom in here, starts at 1, so we're going to plug 1 in for n, so 4 times negative 0.3 to the 1 power. So here we go. Start is 4 times negative 0.3 to the 1 power, which is 4 times negative 0.3, which is negative 1.2. So that's my starting value. So negative 1.2 over 1 minus r, which was negative 0.3. So that's going to be negative 1.2 over 1 plus 0.3. And whatever negative 1.2 divided by 1.3 is. Negative 0.923. So kind of a weird number we converged to here. And we actually, having that negative in there makes this alternate back and forth. And this actually, probably we need to understand this is going to do something different. And we'll see later on in these sets of lessons that D is what we call an alternating series. So it has some other rules applied to it. And I'll probably strike it from the paper so you might not even see it on your paper anymore. Okay, so big picture again. The primary question we ask about series is if it converges or diverges. Our first type of series is some number raised to the nth power. If that number that's raised to the nth power is absolute value of it's between 0 and 1, it converges, otherwise it diverges. These are called geometric series. You need to memorize that name. Now we're going to look at a second type, which is probably just a touch easier. It's called a p-series, and then a type of p-series is the harmonic series. So a p-series is any series where you have 1 over n to a power. Now notice, n is important. On the geometric series, n was our power. N is the number of whatever term number you're on. Well, now our n is getting some weird p. Some p is just some random power. It could be squared, it could be 0.3. In a p-series, n will not start at 0 because we can't divide by 0. Now, I do want to point out that this double arrow here, 1 over n to the p, is the general form for a p-series. However, we've already seen that we can take the number 1 to the power as well, and it doesn't affect it. So a lot of times you'll see it written the second way, and that's also a p-series. Just think of as the p being on the bottom as well, because a power on a fraction will go on the top and the bottom. All right, now, whenever the p is 1, so it's 1 over some number to the first power. That's called harmonic series. That's just, it gets its own name. It's kind of special. You won't see the first power. So if you ever see 1 over n, that's a harmonic series. And so just know that if the instructions say to use a harmonic series, that's what it means, 1 over n. Well, what do you need to know? As long as your p, your power, is greater than 1, the series converges. And if the p is less than or equal to 1, it diverges. So that also means that a harmonic series will also diverge, because a harmonic is when p is 1. Now, this isn't geometric. We're not going to figure out what number it converges to. That's not the point. We're just answering convergence or divergence, which one. That's it. Okay? Note number 4, if you're told you have a harmonic series, then it always diverges. So, these would be like, let's tell whether this series, so the sum from 1 to infinity of, let's go n to the negative 1/2. Does that converge or diverge? Well, we want to get rid of the negative 1/2 and flip it to the bottom. So we see 1 over n to the 1/2. Well, that's now we recognize it's a p series, and we recognize n's on the bottom, and our power is 1/2. And if our power is between 0 and 1, it diverges. So this is a divergent series. It says divergent p series. Let me give you one more example down here. So let's say we have from n to the summation from n to infinity. And I don't know, we could have other numbers here, 4 over, let's say n squared. I mean, maybe it's all squared, doesn't matter. So we could rewrite that as n equals 1 to infinity of 16 over n squared. And so now I see it's something over n to a power, so it's a p series. And according to this instruction I'm circling in red, if p is greater than 1, it converges. My p is 2. That's greater than 1. So this is a convergent p series. So that's how you deal with p series. All right, so I've organized these first two thoughts so that you can keep them straight. So let's just go through this table and we'll be finished with this video. So you're asking yourself, where is n? If it's a number raised to an n power, that's geometric. But if n is getting the power, that's p series. Does it converge? Well, on a geometric, if your r, really I should put r in there, if it's between 0 and 1, the absolute value, it converges. But on a p series, the power has to be greater than 1, so they're backwards from each other. Divergent geometric series, r is greater than or equal to 1, while p series, p is less than or equal to 1. Now notice if it's equal to 1 in either case, it diverges. Finally, do we know what the series converges to? Well, yes, we can do that on a geometric series only. It's the first term of the series divided by 1 minus r. Okay, big picture, and we'll be finished with this video. Remember, highlighted in yellow, the question is the series converging or diverging? And we are going to do a lot of tests, and the first two we've learned now, and that is that you want to see, is it a geometric series, some r, some number to an nth power, or is it a p series, 1 over n to some power? If it's one of those two, you're going to use box 1 or 2, figure out the convergence or divergence that way, and you're done. Unfortunately, there are a lot of series that aren't geometric or p, so we have other tests that we need to do, and that will be in an